All right, so this is, like I said, this is 8.1. This is our first lesson in Unit 8, all about functions. So in this lesson, we are evaluating functions. 8.1, evaluating functions. So I already pasted this on my paper, bottom left, towards the bottom and towards the left of the paper, so that we can kind of start our notes and then we'll continue them down here towards the bottom. So first we're going to talk about function notation. So function notation looks like this. F of x equals 3x plus 4. Now this isn't f times x, which is the most common confusion. This f right here actually is the name of the function. So instead of an f there, a lot of times you'll have f, but sometimes it'll be a g, sometimes it'll be an h. F of x. Where then x, this x right here, that's what tells us what value to plug into the function. Tells what value to plug into the function. That may be an integer value, it may be an algebraic expression. And lastly, we have this part right here. This part right here is the function itself. So now that I have my little notes, I know what a function is and what all the parts mean. Something important to note, how to say this. We read this as, quote, f of x. That's how we read this function, f of x. Now on to our little slider here. Handy dandy little slider. First spot you want to have it is in the f of x equals 2x plus 3 spot. So this is our original format for our algebraic function. F of x equals 2x plus 3. I just rewrote it. Nothing fancy. And then when I slide it down, I have f of 5 equals, now I'm going to go ahead and simplify. 2 times 5 is 10, so I'm going to write that out. 10 plus 3. So f of 5 equals 13. I know that doesn't blow anyone's mind. I'm pretty sure you've all seen things like that before.
Oh, okay.
You're just putting a 5 into the function. Similarly, when we move this down to f of negative 1, f of negative 1 equals 2 times negative 1, which is negative 2, plus 3, which is 1. This should feel pretty easy so far. And we shift it down. So we have f of 0 equals 2 times 0, which is 0, plus 3. 0 plus 3 is 3.
Oh.
Yep. Now we're getting crazy. We're putting an a in our function. I think that I didn't glue it quite right because I'm making a little bump here, but not perfect, but it'll do. So f of a, so now we have an a in the spot where the x value once was. So we write that as 2a plus 3. That's it. We're done. I mean on that one. I'm saying we can't do anything else. But there is one more. Thanks. Man, mine's a little bit of a mess. So this one says f of a plus 1 equals 2 times a plus 1 plus 3. This is where people start to get mixed up because we now put an algebraic expression in for x. But that's why I really like this slider, because it just helps you to see whatever's in this spot is what you put in to the x spot. So, and then from there you just simplify. So that would be 2a plus 2 plus 3, which is 2a, 2 and 3 is 5. So f of a plus 1 equals 2a plus 5. So on your notes, or sorry, on your assignment for tomorrow, things to watch out for would be when you're plugging a negative in, and it's raised to the second power, what do you need to make sure and include around the negative number? Parentheses, right? So on questions like 8 here, if I have g of negative 1, well, that's not what I meant. If on questions like number 10, when I have p of negative 10, if I do negative 10 squared, I better put that negative 10 in parentheses, otherwise I would get a different answer. So negative 10 squared is 100, minus 3 is 97. And then on the back, I'll do another one. So on the back, we start getting into the spot where we have our algebraic expressions. So I'll do 13. So this is where we have g of x plus 3. So where there was an x, we write our new expression. So that's going to equal x plus 3 plus 2. Just imagine your slider right there, filling in whatever's in here into the value for the variable. And then from there, we don't really need those parentheses, do we? There's nothing really that's setting that expression apart. So we can add the 3 and the 2, and we get x plus 5. So g of x plus 3 equals x plus 5. And that's it for evaluating function.